welcome back friends. So, in the previous lecture we gave you an example of how to calculate MMLOS from the point of view of automobile mode. In this lecture we will continue the series and now we will introduce you to developing MMLOS concept for the non-automobile mode, right. And then also finally, we will look at how you develop an integrated MMLOS considering all of the modes together. So, we have already looked at the level of service for an automobile mode and we have seen what are the factors on which the level of service of an automobile mode is based on. Now, when we if you look at the non-automobile mode and start looking at the first non-automobile mode, which is the pedestrian mode, we will see that, and you have already gone through the level of service of pedestrians. What you already know is that the pedestrian level of service depends upon the average pedestrian space and a pedestrian level of service score, right. So, a score is developed by getting the perception of different pedestrians on different facilities of a street. For example, what do they perceive about the sidewalk width, what do they perceive about shade, comfort, all of those things aggregated up to develop a level of service score, and then you actually look at how much average pedestrian space is available for them to walk on. So, an interaction between those two gives you different levels of service. So, that is essentially how you develop a level of service for pedestrians, even when we are looking at it from the point of view of an MMLOS for pedestrians. If you want to develop MMLOS from the point of view of transit or bicycle, it is still at a very nascent stage, and it is all the researchers have been able to develop so far is a level of service for either transit or bicycle using only the level of service score. But however, the score is developed separately for transit and separately for bicycle, but the ranges remain the same, and the level of service A versus B versus C ranges remain the same, but obviously the questions or the variables that are asked or the variables that are input would be different for transit versus different for bicycles. You would again see that the level of service for pedestrians is done in a similar manner as we have shown you for the level of service of the automobile mode. Again, for the entire facility is broken down into different segments, and the segment level of services are individually developed level of service for each of the segments, and then we weighted average of all the segment level of service scores are aggregated up to develop the level of service score for or the level of service for the entire facility. So, a similar model is followed here as well. Even for the bicycle and transit levels of service, you will see that the individual level of service scores for each of the lengths are calculated, and then weighted average of them for the entire length of the facility is developed. So, that is how these things have been started in their implementation, because these are very new concepts. So, as more and more data gets available, as more and more sophisticated techniques are developed, I am sure these will evolve into more robust methods of developing levels of service. But for now, what latest we have is these weighted average levels of service scores for each of these 3 different modes or 4 different modes when we look at the multimodal level of service concept. So, again, if you take the same kind of street segment which we have already calculated the auto level of service, if you remember in the previous lecture, to be C, then now if you have for the same 3 segments, if you have different levels of service scores for your pedestrians, bicyclists and transit, how do you develop, then can you compare the levels of service offered for each of those modes on the same segment. This is the big advantage that has to be driven home, that each of the segments may offer different levels of service to different types of modes. So, it may be good for walking, but it may not be very good for the motorized vehicles, whereas sometimes it may be very nice for the bicyclists, but not so good for the pedestrians. So, same piece of road or same stretch of road, how can you analyze it from different perspectives. This is what MMLOS HCM 2010 technique allows us to do. So, now you have got the free flow speed for this segment, free flow. So, all of you each of these parameters for each of the 3 segments are given to you. So, if you start looking at the pedestrian level of service, the space pedestrian, first you want to understand what is the average pedestrian space. So, if each of the space values are given and each of the length segments are given. So, if you use the formula and get the score, and then if you develop the level of service score for each of the segments, weight by the length of that segment, and sum it, divided by the sum of the entire segments, you would get a value of 3.6. So, then if you go back to the table and you see that your average area per pedestrian is 25. So, which falls between 24 and 40, and then your pedestrian level of score is 3.6, which falls between 3.5 and 4.25. So, if you see the point where these two meet, you will see that it is level of service D. So, now you can already start to think that this gives a poorer level of service for pedestrians when compared to the level of service for motorized for automobiles. For example, it was giving a level of service of C as we saw in the previous lecture, right. So, already you can see the variation in the levels of service offered by the same stretch of road to different modes that are plying on it. Similarly, if you do it for bicycles, remember for bicycles it is only the level of service score that is used as of now to develop to determine the level of service. So, if you know the scores for each of the length segments, you just do a weighted average and you get 3.76. So, a 3.76 level of score for bicycle would mean that it falls in this range, and so even for bicycles it is a level of service D. And for transit, if you do it in a similar manner, you get a 2.89 level of service, which gives you a level of service C. So, for transit and for automobiles, this stretch provides a level of service C, whereas for bicycles and pedestrians it provides a level of service D. So, so you can conceptually now figure out that this stretch of road is more favorable towards motorized vehicles, because public transportation mostly is motorized, some form is non-motorized if you have cycle rickshaws, so on and so forth, but mostly it is motorized, and automobiles obviously are motorized. So, so this way in which the street is designed maybe it favors these motorized modes, hence offers better level of service, whereas if you are a non-motorized mode user, or if you are a pedestrian, then it offers a poorer level of service, which is of D. So, this is an easy way of comparing the various levels of service that a segment has to offer. So, we have gone through all of that. We already know that the for level of service for this has been already calculated in the previous method. So, now we can compare all of that. So, essentially what is happening, how we are measuring all these level of service scores, right. We have to develop the perceived level of service score. We have, for simplicity's sake, we already gave you the scores, but we actually have to develop these scores, right. So, what these scores consists of usually are perceived levels of service or perceived quality of service that various traffic characteristics, geometric design and other features of that road offer to the users. So, when I am walking on the street, I perceive that street in a different fashion, traffic wise, geometric wise and other factors wise, versus another person maybe perceive it differently. So, when we have enough, when we essentially ask enough pedestrians on that street about their perception of different factors, different traffic factors, different geometric design factors, and different maybe comfort factors which are grouped under others, and you then develop a statistical technique to come up with a score. That is what is called a pedestrian LOS score. So, that is the other element that you are using when you are developing a pedestrian level of service. You are not only using the average space for pedestrian, but you are also using the level of service score. So, these scores are coming from either design factors, traffic operational traffic characteristic factors, or other factors which may include for example shown here. So, these are all say comprehensive factors or input parameters that have been used for developing levels of service scores for each of these modes, right. So, when you look at developing the level of service score for a pedestrian mode, you are taking the mid segment flow rate of motorized vehicles into consideration. You are taking the percent of heavy vehicles, no, you are not taking into consideration. You are taking the pedestrian flow rate into consideration. You are taking the proportion of on street parking occupied into consideration. So, these are very, very important to know that what does the pedestrian level of service score depend upon, right. So, the pedestrian level of service score or the bicycle level of service score will not only depend upon the pedestrian mode or the bicycle mode, but there comes the interaction. So, now even though you are walking, but you are affected by the percent of heavy vehicles, you are not affected for example, you are not affected by the percent of heavy vehicles that are plying on the road next to which you are walking, but you are affected by the proportion of on street parking that is occupied. So, if there is on street parking available and what percentage of it is occupied affects the perception of the person who is walking along the road, and that perception when it gets affected, it affects the level of service score. So, these are a comprehensive list of all the data elements that are used for developing these level of service scores. So, you should be aware of this. You should take these as base input parameters at least for your own facility. You should know that these are all parameters that are used in the HCM 2010 method, which is based primarily in the United States, but that does not mean that it may not reflect the characteristics of your hometown or your home city. It may or may not, but at least this is a good starting point. So, you start with this, you see if you get intuitive results of levels of service scores. If you do not get, then you look for other parameters to include in the development of a level of service score. So, this is a good starting point. So, there are different traffic characteristic parameters, different geometric design parameters that are given here, as well as different other parameters. For example, in the other parameter section, you can have the area type, which is residential or not, pavement rating condition may be something. See, it is important for the bicycle mode, but not important for the pedestrian mode, right, because pedestrian usually should not be walking on the pavement. He or she should be walking on a facility dedicated for pedestrians, but in our case, well, maybe in India, see. So, that is maybe something that in Indian case this becomes actually a factor which should be considered in developing the pedestrian level of service score. So, that is what I mean when I say that these input parameters should be a starting point for you to start understanding how to develop a score. Some of these may change based on Indian conditions. That is up to you to look at your local conditions and tweak them in a intelligent fashion. So, now when we start looking at the interaction between modes, this is the last step in understanding how to develop a multimodal level of service when you have actual interactions between the modes, and then you develop a level of service score. So, as we just showed you that how these interactions may happen, right. When you are walking, you are not only affected by other people who are walking, but you may be affected by the vehicles on the road, you may be affected by parking on the road. So, those are all not pedestrian factors, but those are factors from other modes, such as that is in factor from the automobile mode. So, similarly for bicyclists, you may be affected by the volume of heavy vehicles that is on the road, and that is a factor, that is not a bicycle factor, but that is a factor from the automobile mode. So, an automobile mode may affect or may have an effect on the level of service scores of the other modes. So, that is essentially the interaction that we are going to show, and also transit mode will have an effect on the pedestrian level of service, and the the pedestrian mode will have a effect on the bicycle level of service, and vice versa. So, there will be a lot of interactions, and when you see those interactions at the end of these slides, you will understand that how complex this concept of multimodal level of service could be when you actually develop or when you try to develop one score, for example. We have not yet ventured into developing one multimodal level of service score. We are still at the level of having multimodal level of service score developed for each of the modes, but for one specific facility. So, that is where we currently are. We have not the state of the art has not developed or not developed a combined level of service and shown it for the entire for the facility. We are showing it for individual modes, but if you start understanding the interaction, that is when you will be completely getting the depth of the problem that we are handling. Okay. The urban street level of service for a given mode is the average degree of satisfaction with the urban street that is reported by a large group of travelers using that mode if they had travelled the full length of the study section of that street. So, these are some of the nitty-gritties that you have to keep in mind when you are doing the survey, right. It is not you should be not asking a person who is maybe a leisure traveler. Maybe he is from he or she is an out of city traveler who has come here for leisure, and then if you ask him or her how good is this facility, then it would not be a representation of the people who walk on that street every day, for example. So, when you do all this, you have to keep in mind how to sample, how to develop how to create your sample size, what sampling, whom should you include in the sampling. You do usually do random sampling, but the random sampling should include people who walk there more often than not, right. So, you have to be very careful when you develop your samples for these level of service. So, now if you start looking at the interaction between modes, there are 37 different variables to predict the perceived level of satisfaction or degree of satisfaction. These 37 variables are divided into 4 types. One is the facility design. So, what are the parameters that affect the design of that facility? Facility control, whether it is it has signalized intersections, unsignalized intersections, access points. Remember the diagram that we showed about the entire facility. Transit service, whether that piece of that stretch of road or that facility actually has bus routes, metro routes, does it or does it not have, does it have multiple routes. So, all that goes into account, the factors go into account, and the volume of all of the modes. Obviously, how much volume of transit is there, automobiles are there, bicycles are there, pedestrians are there. All of these 37 variables are grouped under these four factors, and then we see that these individual parameters, how they interact amongst each other to develop the level of service for each of these modes. For example, the auto level of service model 1 and 2 uses only 4 variables. So, you can develop an automobile level of service using one of the 2 models that are shown here. The model 1 develops it based on delays or the presence of left turn lane, whereas the level of service model 2 develops it for using mean speed and the median type. So, you can choose one or the other in order to develop the automobile level of service, but they use only 4 variables which are shown here. So, these are the 4 variables that are shown here. These 4 variables differ for different types of facility design. They differ, this variable differs by facility control. and obviously all the volumes of the different modes will have a bearing on that variable. So, this is what this entire table allows you to look at. It tells you what are the inputs for the level of service models for each of the modes, and how do that input variables vary by the type of categories that we have classified them into. So, does the delay depend upon facility design or facility control? Obviously depends upon control, because if it is an unsignalized intersection, the delay will be different versus if it is a signalized intersection. So, it depends upon the facility control of that piece of road, for example, whereas the left turn lanes, the presence or absence of left turn lane is not a control feature, but it is a design feature. So, that is what this allows you to tell. This shows you essentially XXX indicates the input variable is influenced by that factor. If you see automobile mode, you have only 4 variables by which you can develop a level of service, whereas if you start looking at the other levels of service, for example, the transit level of service, that uses 6 variables, 1, 2, 3, 4, 5, 6, and these 6 variables are grouped or are affected by various things in this table. For example, the pedestrian, one of the variables that has an impact on the transit level of service score is the pedestrian level of service. So, this is the interaction. So, maybe higher the pedestrian level of service, the better is the transit level of service score as well. So, this is an interesting interaction that you can immediately see how one mode is affecting the other mode, right. This is what we mean when we say that there is interaction between different modes, and their interaction actually affects the level of service of different modes. So, you can easily follow through all of these. When we talk about pedestrian volumes affect signal timing, which affects the delay for pedestrians and buses, and hence affects pedestrian level of service, right. If you have a high number of pedestrian volume, it may at a signalized intersection, then there may be greater green needed for the pedestrians to move, that may impact the green time for the transit, and hence the transit level of service may be affected. So, those are all the various interesting interactions these different parameters have with different for different levels of service of different modes. Now, when we start looking at the bicycle mode, you will see that it becomes even more complex, but where the bicycle level of service now uses 10 different variables in order to develop a level of service score. So, you see how we are gradually getting more and more complex, where automobile mode you could just use 2 variables per model to develop a level of service, whereas transit needs 6 variables to be now collected from the field. Bicycle level of service now has to collect 10 variables in order for them to develop a level of service score. And then when you get into pedestrian level of service score, this is the something that gets really complex, because now you are dealing with human beings who are walking, and their perceptions may vary by age, gender, occupation, multiple things. So, now it becomes very difficult to just capture the level of service score using few variables. Now, you have to have a whole lot of variables to actually capture the level of service. And then when we talk about interactions now, there are vehicles per hour also has a bearing on the pedestrian level of service, right. If you see that, let us look at the bicycle. So, pedestrian bicycle conflicts has an impact, and that is directly related to the bicycle volume. So, that has an impact on pedestrian level of service. Transit also transit vehicles per hour has an impact. Right turn on red. So, that will be left turn on red for our case, because we drive on the left hand side of the road. So, if your permitted free lefts, then that has an impact on pedestrian level of service as well. right, because pedestrians may be crossing that road and you have a free left, and then there may be a conflict point may arise. So, you see when you are developing pedestrian level of service, now you have a whole lot of variables that can influence it, and then it becomes very complex to develop the level of service. So, if you put all of these together now, if you put all of these together to actually see how the interaction between the modes occur, you have your groupings on the top, and you have all of these different variables shown in shown as arrows here. You start to observe that the number of arrows that feed into the automobile level of service is much fewer when compared to the transit level of service, which is again much fewer when compared to the bicycle level of service. And finally, the pedestrian level of service has so many arrows that are coming in from different directions, which makes it even more complex to develop a pedestrian level of service when actually you are looking at the interaction. If you had to just consider for example, developing a pedestrian level of service for an off street trail, for example, a trail that goes through a forest area, and you want to develop a level of pedestrian level of service for that trail. Now, that is an easier task to do, because on that trail there is nothing else, no other mode that can go through, right. So, there is no interaction with other modes, you only have people to people interaction, pedestrian to pedestrian interaction, and the level of service for developing a level of service score for such a facility would be easier. Then on the other extreme, if you want to develop a level of service score for an expressway, all right, and on an expressway no other modes are allowed other than vehicular modes, right. It is restricted for a non-motorized transport, and obviously it is not restricted for buses, public transit, but just by the nature of the design of the expressways, no public transport runs on it. So, when you are trying to develop a level of service score for automobiles for expressway, it is much simpler than when you want to develop a level of service score for an automobile mode for an urban street, or maybe an urban collector or an urban arterial, right. So, why is it difficult? You can see it now in this picture, that because there is interaction with other modes. Now, this interaction with other modes makes things very complex, but we have given you a very simplistic methodology by which you can do it, the HCM 2010 methodology, where you can calculate the level of service scores for each of the segments, and you know how to now develop the level of service scores, because we have shown you what input parameters can you use, and those input parameters you can then take to develop a questionnaire, survey questionnaire for your city or your town, and get the perceived values from the responses of the citizens that are using those facilities, and then develop a level of service score. Using those level of service scores for each of the segments, you can then average it up using the lengths, based on the lengths, and develop the level of service for the entire facility. So, I hope that this has been very helpful to you. This is a concept that is clearly in the path of evolution still. A lot of research is happening. This is a new avenue that transportation researchers are engaging in, and also policymakers are more and more getting interested in this, because many cities are now choked and congested, and they want solutions to ease this congestion, and they can develop solutions only when they know where the problem is the problem with the pedestrian modes, is the problem with the automobile modes, is the problem with the transit mode. Unless they know that, they cannot offer a pointed solution. So, this is something that is going to help everybody, and everybody is going to be in need of this in the near future. Again, the references are given here. The highway capacity manual is a reference that we have been following for a long time, and so has been the NCHRP report. Please read through them carefully. So, in conclusion, what we have looked at today is the non-automobile mode LOS, including pedestrian, bicycle, and transit. We have shown you what are the input factors for developing the LOS score. Remember, the LOS score is then divided up into different ranges, which then in turn tells you the level of service for that facility. So, all the 37 different variables across 4 modes were shown to you, and then we showed you the interaction that these variables have when the level of service is developed. Thank you very much for your attention.